Hello everyone, and greetings from Cambridge in England. Step inside the Oude Kerk in Delft in the Netherlands, and beneath its leaning spire you will find this memorial. It commemorates Antony van Leeuwenhoek, the Dutch investigator who launched microscopy as a science. Leeuwenhoek died 300 years ago. He was one of the greatest scientists and investigators in the history of the microscope. His tombstone is set into the floor, recording him as a great man of science. His devoted daughter Maria, who supported him in his astonishing career, is buried with him. He died on August the 26th, 1723, and had been born on October the 24th, 1632. He'd been christened Tonys, not Anthony, and he laid the groundwork for today's understanding of microbiology and the use of a microscope to solve a vast range of intractable problems. Yet he left behind problems of his own, such as, how do you pronounce his name?
Anton van Leeuwenhoek.
Antony van Leeuwenhoek.
Antony van Leeuwenhoek.
Anton van Leeuwenhoek.
Anton van Leeuwenhoek.
Anton or Antony van Leeuwenhoek.
Leeuwenhoek.
Anthony van Leeuwenhoek.
Anthony van Leeuwenhoek.
Anthony van Leeuwenhoek.
Anton van Leeuwenhoek.
Antony van Leeuwenhoek.
Anton van Leeuwenhoek.
Antony van Leeuwenhoek.
Anton van Leeuwenhoek.
Van Leeuwenhoek.
Anton van Leeuwenhoek.
Let's hear how a Dutch scholar would pronounce it.
Antony van Leeuwenhoek. 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 Antony van Leeuwenhoek.
That's the first problem. The second is, what could you see with a Leeuwenhoek microscope? This problem I solved more than 40 years ago with this specially designed focusing bench to hold the diminutive microscope. It allowed me, for the first time in history, to record in colour what the lens could reveal. In this unstained preparation of my own blood, not only do the red cells show clearly, but just above the centre and to the right, you can see a white cell with its nucleus clearly visible. Look very closely at that part of the micrograph and we can see the unmistakable nuclear lobes of a mature granulocyte with red cells nestling nearby. This is an astonishing result for a single lens microscope. The third problem was, how did he prepare his specimens? This conundrum I solved in 1981, when Sir Andrew Huxley, the President of the Royal Society, suggested I might care to examine Leeuwenhoek's original letters. They'd been consulted in microfiche by Dutch historians and by scholars including the great and unsurpassable Clifford Dobell, whose widow Monica I came to know well. But no one had looked closely at the original letters themselves, and to my immense surprise, I was to make a discovery that even the great Dobell had overlooked. Attached to the letters were specimen packets, 9 of them in all. Dobell had noted the little envelopes, but he never thought to examine what lay within. Inside were exquisitely fine specimens. I was able to take small samples to the Netherlands and examine them for the first time under an original Leeuwenhoek microscope. We could see his specimens through a microscope that he is said to have made. Leeuwenhoek's view is on the left. On the right are the same cells of his Eldepith section seen under a modern light microscope. The view is better, but not as much as we've been taught to expect. Nobody had ever seen one of Leeuwenhoek's specimens through a Leeuwenhoek microscope since the day he died. This is one of his excellent sections of Eldepith. And here is a Leeuwenhoek cork section, again imaged through the Utrecht microscope. These images, at high resolution and in colour, were unprecedented. Nobody has come close to reprising single lens micrographs with such clarity. Here is the best I could find, published by Getty Images and hailed as a success. I personally regard that as a failure. Some of his specimens were of pond life, and I could restore them to lifelike appearance. Leeuwenhoek himself observed the revival of dried rotivers, and here near the centre is one I've identified as Trichostocha cristata, that does not have the appearance of an antique specimen. These blue-green algae, Anabina I assume, appeared to be viable after 3 centuries in storage. Small portions of the sections were examined under the scanning electron microscope. This view seems to be of a leukocyte with surrounding bacteria, though it would take EDX analysis to prove the point, and the Royal Society has so far not agreed to re-release the specimens for further analysis. After scrutiny, the specimens were carefully mounted and stored in closed containers, so that scientists of the distant future can return to them and carry out analysis of a kind not yet invented. There were many papers published in my early investigations, and my extensive research into the microscopes and the details of my analysis with light and electron instruments, all of them fully illustrated, were comprehensively set out for scholars in my book, The Leeuwenhoek Legacy. However, my research was being regularly plagiarised. The Boerhaave Museum in the Netherlands arranged an exhibition in London and Leiden that featured the specimens I'd discovered, but with no mention of any of this research, as if they'd unearthed the samples themselves. They had Brian Bracegirdle attempt to reprise my experiments with the elderpith sections through the Leeuwenhoek microscope at Utrecht. Bracegirdle's results are on the left. My earlier image of the same specimen, under the same microscope, is on the right. The same museum still publishes my photograph of Leeuwenhoek's bovine optical sections without attribution in their descriptive booklet. They didn't rephotograph the specimens. This example, with its characteristic hooked outline, is one I'd already removed for coating with gold for the electron microscope on day 1. Professor F.C. Rodsman includes my blood image, attributing it to the Utrecht University, in his work, A Histologica Classica. He also publishes pictures of my Robert Brown microscopical research, without any attribution. Indeed, there seems no end to the number of people who have endearingly plagiarised my research. The latest example is Eric Jorink in the Netherlands. He's been given a grant of €750,000 by the Netherlands Organisation for Scientific Research to repeat the very first experiments of scientists like van Leeuwenhoek, using original van Leeuwenhoek microscopes. This way we can see for ourselves what they could see and how they expressed it. That's all research I completed well over 40 years ago. Yet formally employed academics like to claim a unique expertise when it comes to matters of the microscope. This on the right is Sir Paul Nurse, when President of the Royal Society. Here I am visiting the institute that he set up, the Francis Crick Institute. Paul raised millions to set it up. I've not yet seen anything particularly notable that they've achieved, though I expect that's just my ignorance. Step inside, and one of their display cases features this eye-catching poster, which emphasises the importance of the academic environment. Amateurs have no place in the specialised world of microscopy, the public are reassured. They might manage a magnifying glass, but it would take skill and experience to capture crisp images with a powerful microscope. They might have added and training. This tiny microscope has a lens ground from the mineral spinel by Horace Dall of Luton. Magnifies 400 times. This is a picture of the head of a louse that I obtained with Horace's microscope. These are Chaluta spores sprouting out of wheat. Here is a section of fern root and living spirillum, spiral bacteria, seen with a single lens. Spinel has rather lower dispersion than soda glass, so these images are probably the very best you could ever get with a single lens microscope. My colleague in Cambridge, S. Reed, is our leading lens designer. He's the man behind the mesolens microscope, and he created some exquisite single lenses for my experiments, magnifying between 50 times and 200. The lenses themselves are tiny, as you can see, less than 1 millimetre in diameter. Let's start with a superb video micrograph of the protozoan Euplotes. filmed by one of the greatest micrographers of his generation, Canadian photographer and wildlife enthusiast Robert Bairden of Calgary, Alberta. See the caudal cirri on the left, which act almost like little limbs, and the row of cilia that draw food into the cytostome, the mouth. But under a single lens microscope, this is the picture that we get. This is times 200, taken with the S. Reed lens, and although you don't see the detail, the amount that you can see is really quite surprising. Even under low power microscopy, with a single lens you would recognize Euplotes, and you could essentially study the way that it lived its busy life. Under a very low power single lens microscope, magnifying just 30 times, this is what pond ciliated microorganisms would have looked like. This is the view that Leeuwenhoek would have had that day when he first studied microorganisms and wrote about them with such exuberance. Here is Stylonychia hunting around amongst some filaments of Cladophora, filmed with a botanical Victorian microscope. Again, a single-lensed instrument. Under the best of S. Reed's lenses, magnifying times 200, this is how Stylonychia looks. That really is quite remarkably clear for a single piece of glass. Here are dinoflagellates in a sample from seawater, busying themselves and photographed under the 50 times single lens. Put them under the higher magnification lens, and this is the view that you get. If you were to show that in a conference, I don't think most people would assume that it was taken with the same kind of single lens microscope that Leeuwenhoek himself might have used. This is the rotifer Brachionis. They're busying themselves in a small sample of seawater. And here, through a single lens botanical microscope, here is Loxophyllum, exploring busily around in the corner of a pond. We all studied paramecium at school, or I hope we did, and this is what the single lens microscope would reveal of paramecium. This is the kind of view that Leeuwenhoek would have had in the 1600s, and we can now see it for the very first time in history. He also drew Vorticella. Here is one under a low-power single-lens microscope, and one can get a perfectly good idea of its structure, its morphology, and how it combs the water by setting up a vortex that draws food particles in towards the cell. If you look at it under a higher power lens, it is possible to study the way in which Vorticella draws back when disturbed, and then unravels its spiral stalk, ready to recommence feeding. Now, at a very high power, you can of course see the cell with greater detail. But as the detail increases, the contrast of the image becomes reduced, and really, although it's possible to get a good view of the cell, you don't gain an awful lot by looking at higher magnification. Here you can see the vacuoles and food particles circulating within the cytoplasm, but you can often get a better idea of exactly how these organisms live their lives by looking at them with lower magnifications, so the whole cell in its environment can be studied. The unending quest for higher magnification and better resolution sometimes defeats the object. I mentioned a botanical microscope. This is an example that Robert Brown used. It was made for him by Robert Banks and Son in London. It's a beautiful little instrument, and engraving on the circular stage shows that he was a maker to the Prince of Wales, later King George IV. Many people used Banks microscopes. Robert Brown, the botanist Bentham, Charles Darwin was still using one in the 1850s. Robert Brown is best known for his association with what we now call Brownian motion, but he's also the person who named the cell nucleus, and the BBC have tried to recreate that experiment without success, as I've shown at this meeting before. Yet, under the lowest power magnification of Robert Brown's microscope, you can indeed make out the nucleus. Look under medium power at exactly what it is that Brown is observing, live. This isn't a still micrograph after all, and the clarity with which the nucleus can be displayed is really quite remarkable. Even under the highest power lens, we can pick out just one single cell, and there it sits with its nucleus clearly visible. Brown studied much botanical microscopy, and here we can pan across a section of pteridium, the fern stem, and see here its abundant cortical tissue, surprisingly well resolved. And I do want you to notice that although people criticise single lens microscopes in theory, never having used them for all their chromatic aberration, and there is a hint of chromatism in this image, but of course it doesn't interfere with the clarity with which you can observe your specimen. Those early microscopes were surprisingly well adapted to serious scientific investigation, and the images they created were not as full of aberrations and colour distortions as most contemporary scholars would have you believe. You can see quite clearly the cells of the xylem and the other tissues as we pan across this section. These are indeed extraordinary results, and this collection of video micrographs is unique and unprecedented. The techniques I developed also help us solve certain enduring mysteries in the history of the microscope. This is a plate from Robert Hooke's book, Micrographia of 1665, showing the microscope he used. It was made in London for him by Christopher Cock. Look inside and you will see exquisite engravings like this remarkably detailed study of a mosquito larva, Culex. See all those tiny hairs, all the details of the mandibles and the internal structure. Yet if you look through a Robert Hooke type microscope, this is all you see. Yes, there is the mosquito larva, it's quite unmistakable, but you don't see the details of the hairs, and you certainly can't see details of the interior. But under a single lens microscope, this is what you see. All of those hairs, exactly as Hooke portrayed them, are faithfully reproduced. And yes, everyone, if you use a single lens microscope, you can see the detail. It is only with the compound microscope at that time that you couldn't. And the truth is, Robert Hooke used a single lens microscope, not his great compound microscope, to fill in the details of his great engravings. What he showed through his microscope, you cannot see through his microscope. He used a single lensed instrument instead. This is the view that Robert Hooke would have had through his microscope of the flea. But compare that with the majesty of his engraving, a great fold-out plate, a couple of feet long. Just look at the detail in that. And of course he mentioned, hidden in the unnumbered pages of his preface and overlooked by all previous scholars, that he had used a single lens microscope to fill in all the details. This is what the flea's leg looks like under a single lens microscope. And now suddenly the details of the hairs that you can see quite clearly portrayed in Robert Hooke's most vivid and appealing engraving are easily visible. But you didn't see them through his own microscope. It was the single lensed microscope that gave him the detail his engravings needed. As we pan across the leg of this flea, the amount of detail that is revealed by the single lens microscope is really quite extraordinary. And here is his momentous engraving of a head louse. I dare say in the 1600s he had no difficulty in obtaining a plentiful supply of these insects. Under the single lens microscope, this is what we see. Look at the claw, so vividly resolved. The very fine chitinous hairs that feature on the surface of this insect. And if we very gently pan across the body, looking at the segments that are quite clearly portrayed, we come across the eye of the louse. And let's just have a look at that more closely. There you can see the lens and the retinal cup. Yes, these are details that Robert Hooke could show in his engraving because he used a single lens microscope. That is the key. I now have more than 3,000 black and white photographs, many of them scanning electron micrographs of Leeuwenhoek's original specimens, over 1,000 colour photographs on film at higher resolution than you could get on digital media, and more than 120 video sequences recreating exactly what it was that Leeuwenhoek and the other pioneers could see through their primitive microscopes. It has been such an exciting journey over more than 40 years, and I'm so pleased that today I could share the joy of that research with you all in Chicago.